So R2 is V out minus 1,25 divided by 5.73 times 10 to the power minus 3. So we know that 1,25 is actually Vref, that's a reference voltage. So I can go ahead and enter my formula in here. So V out, so R2 is V out, right? Now we do have the voltage there, so V out minus 1,25, okay? Divided, so this is divided by what? By 5.73 in engineering notation, so that will be E negative minus 3, okay? So that's 10 to the power minus 3 in engineering notation. Now we do not have V out, so I have to just replace or change this to be V out, okay, so that we do not get any errors. Okay, so that's V out. Now, so 1,25 is a reference voltage, so I'm going to just change this and say Vref. Then I will come into my header file here. I'm going to make a define, so I will make a variable definition of Vref as a constant, okay? So that will be pound define. So that will be pound define Vref, and Vref is equal to what? 1.25, okay? So in case we want to use I adjust also in another formula, so we can also define I adjust as a constant. So we're gonna have I adjust, and we saw that this current is actually 50 micro amps, so that is 10 to the power minus 6. Okay, so these are my constant. So I can come back into my source file here and my function fixed output, and basically have Vref in here, and everything should be working. So let's try to compile this and see where we're going with this, because we do not want to write a lot of code and then there will be a lot of errors. Okay, there we go, there are errors. So the first one here is error conflicting. So variable output, well, this is a function. Where is it conflicting? The only place is we did a variable function prototype somewhere. There we go. Okay, so we're missing void here. Okay, so I think that should clear the error. Then there is a couple of warnings. The warning, they will go away when we're done writing this. Okay, they are unexpected tokens, so okay, we need a semicolon here. Now let's try run it again. If there will be other errors, we will find out. Okay, well, it seems like it went through. There we go. Please make your selection. Well, we can make a selection right now. We make a selection. Please enter the desired output voltage. So if we want 5 volt, now let's go ahead and try to display what we are calculating, because we are calculating the value of R2. So I'm going to call a printf statement here. Before I do that, I'm going to call the goto, right? The goto xy, and I'm going to put this on the y coordinate to be 12. Then here I'm gonna call my printf. So printf. Now in the printf here, I want to display the value of R2. Now we know that R2 is a float, so it's going to be %f, and we want to display 2 decimal places. Okay, so then I'm going to pass the value of R2 here. Okay, because we are calculating the value of R2 for a particular 5 volt. Okay, so now we know that if we want 5 volt, we did make a calculation that R2 should be 654 ohm. Now let's see if we're going to indeed get a 654 ohm based on our function input here. So I'm going to basically call a sleep function here, so we can see display our result on the screen. Let's go ahead and run this. Okay, so option 1, please enter the desired voltage. So that's 5. As you can see, it's 654 ohm. Now we keep getting invalid selection, and to get rid of that, we must just come in here and we're going to just add the get car function here. It will just sit there and it will prevent us from getting that invalid selection. That is because we are having two loops that are running, checking into each other. So let's just check again if that is gone. All right, so option 1, okay, we want 5 volt, and then it said the resistor must be 654 ohm, and then we've returned and there is no more invalid selection entered. So that issue have been fixed. Right, so now tabulating and displaying our result is another issue on its own that we need to fix. So what I'm going to do here is I'm going to add another variable. Okay, so I'm going to add variable R1. Okay, so this will be just for display purposes, because we want to say, okay, according to our design here, if you choose R1 to be so and R2 to be so, your output voltage is going to be so, based on the fact that Vref is 1,25 and your I adjust is 50 microamps. All right, so now in order to display, so what we're going to display, we're going to display R1, we're going to display R2, and we're going to display output voltage. Okay, so but we need to do some kind of a tabulation. Now the tabulation that we're going to do, basically it's going to be a function that is going to display the heading for us. So we display the heading function and then we're going to pass parameters. So I'm going to call that function inside this function. Okay, so we're calling a function inside another function, and that function we're calling is called heading. So we're gonna name it as heading. Okay, now what will be going on the heading there? What will be going on the heading will be R1, R2, and V out. Okay, because we want to tabulate our result. Now let's first fix this function description. So what's the output of this function? Now this function is basically, it's not returning anything, so it's just doing a computation here. So we can say output will be none. Now I'm going to copy this, right? I'm gonna copy it and then I'm going to display it here. So I will just paste it here, and this will be the function heading. So I'm gonna say void heading. Okay, so now I've got my heading function, and let me copy this into the function prototype. So my header file, function prototype. Okay, so we will not be having errors unnecessarily. So now I need to create the heading. Now the heading that I need to create is going to be basically, I need placeholders, okay, for R1, for R2, and then for V out, so that I can have them display onto my screen properly. Now inside the heading, the first thing is we're going to first clear our console window. Okay, so we clear our console window with system, and then we pass parameter CLS. Okay, then on the next line of code is going to be go to XY. Now go to XY, we give the coordinate 2010, right? Coordinate 2010, and then we want to print F something. So what are we printing here? We're going to print LM317 calculation. LM317 calculation, then maybe parameters. Right, you put what you want to put there. Okay, LM317 calculation parameters, and then we call another go to XY, and 20, this time around 11, and here I will print F, basically just the double the equal. That is just to underline what I just wrote up there. Then the next will be go to x, y again. Now here I'm going to pass the first heading, that is going to be R1, and then R2, and then the output voltage. So let's say 20 and 13, right? And I'm going to print F here, R1. Now because I want to print also this the unit, which is ohm, so I have to pass percentage C here, form a specifier for character, and here I need to pass the value for the ASCII table, the ASCII, and here I need to pass the equivalent ASCII number for character ohm, right? So which is EA. So EA is the corresponding ASCII value for ohm. So when I print like this, then I'm going to have R1 will display ohm. So let me go ahead and copy this. So I copy that, and now this is going to be R2. But because I'm playing on the same y-axis, but I have to shift it. So I'm going to shift it a little bit, maybe by 40, right? So that they don't sit on top of each other, but they remain on the same y-axis, okay? On the same coordinate on the y-axis, okay? Then I'm going to copy another line here, and this is going to be 60, okay? And this is going to be V out. V out will be in V volt, so I just need to write it there. I don't need to hard code the ASCII character for V. Okay, so let's go ahead and give this a try. Where are we calling the heading? Now remember, we're calling the heading here, and so basically this is another function that is going to display the result. So let's go ahead and run this. Maybe let me just cut this. Let's just remove this. Okay, and inside the heading I'm going to call the sleep, and I'll pass 2 seconds. Okay, let's give it a try. Okay, so what are we having here? So option 1, resistor or voltage 5 volt, and then we got R1, R2, and then we got our ohm. So you can see that we have something that's going on here, R1, R2, and then V out. Okay, so it seems like that part is working. So our heading is working with the corresponding coordinate. So every time we need to display something under specific heading, we have to make sure we remember this coordinate very well. Okay, so now we need another function that is going to be the display function that will actually take the result and display them. If we do not need that, if we don't do that, then we can basically just here, after calculating, calling the heading, then we must just display the value of R1, R2, and V out. Okay, so the desired V out that we wanted. So if I hard code that, I can basically just copy this, right? So I will copy this. Now this is why I'm saying that this can be another function that you can actually do for that. So I copy that. Let me just make sure that this thing is tabulated well. So now here, this is where we basically going to display the value of R1 and R2 under these headings. Okay, now we know that the value of R1 must be under R1 heading, which is located at 2013 coordinate. Okay, now because we do not want to place it right on top of R1 heading, so we're going to move down. Okay, we're going to move down from the x-axis, from the y-axis, but we're going to remain on the same x-axis so that it's right under. So I'm going to move this to well, let's put it 15. Okay, and this is also going to be 15, and this will also going to be 15. But now this is going to be the value of R1, which is a float, so it's %.2 f for a float. Then we're going to pass the value of R1 there, and this is going to be the value of R2, which is a calculated value, also a float, right? Then I'm going to place R2 there. Then here is going to be V out. Now V out also a float variable. Okay, then we're going to pass V out there. Right, now let's try to run this and see what we're going to get. Right, okay, so option 1, 5 volt, and well, okay, so my values are coming, but they are disappearing right away. So that is because of this slip here. So we need to move this slip somewhere else. So that's not a place to sleep. We need to sleep perhaps somewhere here. We need to sleep for 2 seconds. So let's try again, so that both the headings and this will be executing at the same time. Okay, now we can go ahead and hit 1, and then our 5 volt. Then boom, you can see we have something that's going on there. So 5 again. Okay, there is our R2 well calculated, but we're getting a negative value for R1, and that is because there is no value of R1, so it's getting any random value that is, and it is assigning it to R1, and this open bracket or close bracket must also be removed. So now I'm going to assign or initialize R1 to be equal to 220, or I'm going to make R1 a constant. It's fine. Let's define R1 here, or maybe make it a global variable into this. Okay, so we're going to make it R1, it's a float. Okay, so I'm going to say float R1 is equal to 220 ohms. So that is the value of R1 in my circuit here. Okay, it's 220 ohms. So I'm gonna remove R1 from here so that there is no double declaration. Okay, so now let's try again. Okay, now I'm gonna select 1, 5. There we go. So R1 is 220, R2 is 640. It's just moving quite fast. Let's give it at least 4 seconds so that we'll be able to see exactly, because 2 seconds is quite very fast. Okay, 1, 5, and there we go. It's 220, 654, and 5 volt on the output. Now let's say you want 3.3 volt. Okay, let's say you want 3.3 volt, right? So that basically means you need 357 ohm on R2. So if you put 357, right, and you will be able to get your 3.3 volt on the output. Now I do not have 357. If I had a 357 right now, I would have inserted a 357 so that we can see indeed how it does work. But obviously we are seeing here when we putting this resistance, because this is 670 ohm. I think that what we measured. All right, it was not 654, and we're getting 5.2, so it is slightly more than the calculated value, because 654 that we are seeing here, right? Let's say we say 5.2, okay, then we're getting 689. Okay, so that is exactly the value that I actually calculated. So let me maybe just probe this value again here. Let me just probe this again so that we can see exactly the value of this resistor. Okay, it's 670 ohm. Okay, 670 ohm, and we are getting 5.27. So it's basically 5.27. So 5.27. Okay, and that give 700 ohm, 700 ohm. But you can see there is a little bit of voltage that is dropping as well. So you have to take account of tolerances of other elements, and obviously this is sitting on a breadboard and so forth, and also this multimeter has to do measurement and all of that. So we're not getting, so there is a plus minus 2% of discrepancies into what we're getting, but we can clearly see that it is exactly that. So if I select again option 1, I say 5.27, as we can see on our screen, and it's saying that I need a 700 ohm resistor, but we measure that resistor, it's about 670 ohm. So it's basically 700 ohm. Right, now we're going to move to the next calculation here, because if I hit 2, okay, if I hit 2, I'm not getting anything, right? I'm not moving anywhere. Now 2 here should be as per this potentiometer here. Now the potentiometer here is 10K, right? This is a 10K potentiometer. If you guys can see, it's a 10K potentiometer. So we're going to hardcore the 10K potentiometer, and then steps maybe into 10 ohm ranges, right? Every 10 ohm or every 100 ohm. I think we can step every 100 ohm and see what are the possible output voltage that we can get. Right, now to do that, obviously we need to create another function. Now this is temporary. We can place this inside another function if we want to, so that we can just pass the parameters, or you can leave it like that. It is doing the job. But for now, we are going to move into the variable output. Now the variable output, we're gonna make use of this equation. We're not going to use the same equation. Now we're going to basically just use this equation to get V out, because R1 and R2, so R2 will be based on the potentiometer that we're going to be changing, right, stepping in every 100 ohm, and R1 will remain hard coded, that's a 220 ohm, and I adjust and Vref are also already defined into our problem statement there in the header file. So we're only going to calculate V out using this equation here. Right, now the variable output voltage function will receive a parameter, right? The parameter will be of type integer, and we're going to call this R port. So this is a parameter that it's going to receive, R port. So here input is well, R port, okay, potentiometer. Right, now the output is basically just going to display the result. Okay, now I need to update my function prototype before we get into trouble. So this function prototype here need to be updated. Okay, and then on the main function as well, where we are actually calling this, we also need to pass a parameter here. Now this parameter that we're going to pass here, we can basically just define it here. Because it's a potentiometer value, we can make it an integer variable. So we can say int port value. Okay, port value is equal to what? It's 10K, so I'm going to say 10,000, right? So that's 10,000, so which means I'm going to take the port val, right? So I'll take port val and I'm going to pass the value of the potentiometer here. Okay, so this basically means when I execute this function, I'm going to have this output here. Okay, this output here is going to be the 10,000 of the potentiometer. So the next thing I have to do is basically to, first of all, the heading. Okay, so heading, right? So I must first tabulate my heading. Now I need to display my result under the heading. Now the first thing I'm going to do here is to create a variable that will be doing the increment for me. So that will be count, that's the variable name, and then I'm going to display the heading. Right, so now I have a heading display. The next thing I have to do after displaying the heading is I need to compute, right? I need to compute the result of this variable potentiometer that's going to display my output voltage. So I'm going to use a for loop. Okay, so I'm gonna call a for loop here. So for what? For count, right? Count is equal to so where do we start? Now let's say for count is equal to 10. Okay, so we start there by count is equal to 10, and then we say count is less than what? Our port, right? Remember, our port was hard coded to be 10,000, that's 10k. Okay, and then we want to increment count by a certain value. So this value you can choose it, right? If you want to go by 100, 125, 130, 150, that's up to you. So now let's choose a random value like 125. So we want to increase or double our resistance every by 125 ohm. Okay, so then we can go ahead and execute something in the while loop. Now in the for loop, now inside the for loop here, inside the for loop, we're now going to use this equation here, because remember we are going to now get the result of the V out based on different values of what? Of R2. Okay, now this R port here is going to be equal to basically R2 into our equation. So what I'm going to do here is I'm going to say R2 is equal to R port. Remember, that is going to be incremented every time we cycle. Then we need to execute V out equation that must be equal to, where is the equation again? So that is equal to Vref, okay, times 1 plus R2 over R1. So we need Vref, okay, so Vref times, okay, so that's going to be 1 plus, okay, R2 divided by R1. So we don't have to compute these first mathematically to basically reduce the equation. So we can just plot in the value, we should be fine. So it's Vref times 1 plus R2 divided by R1 as per this equation here. Okay, and this plus I adjust times R2. So we can just say plus I adjust, all right, times R2. Basically something like this. Okay, so now if this thing does not give us error, we should be able to get the value of V out for every value of R2, which is basically based on the potentiometer value as we've defined here. Because when we change R port, right now, actually here we're going to get into trouble here. This should be count, not R port, okay, because R port is basically what's going to be our exit condition. So we are increasing count here, so R2 must be equal to count. So that's a new value of the potentiometer. Okay, now another problem that we can encounter here is this variable must be done global variable. So I'm going to remove them and put them right here as global variable. Okay, then we can go back into our function here. Okay, so this is now going to be v out. Now this is going to be a for loop, right? So which means it's going to run. Now if I print f here, so if I print f, okay, and then say, well, percentage point to f, okay, and then I pass v out, right, which is a float, okay, which is a float. So that's going to be the output voltage for every value of R2. Now it's going to display, it will be changing. So now I can come here and say go to xy, okay, and then I pass the coordinate. Now remember, we are only going to be displaying, we haven't been calling the heading, have been called already there, but I want to first display v out. So the coordinate for v out, the heading for v out, we need a heading for v out. The heading for v out is 6013. So like we did here, it must be 6015. Okay, so I'm going to go to 6015. Then it will write on top of each other. So let's just test, okay, and see what we're going to get. Okay, so now we're here 1. Okay, not 1, we've done that already. Let's get out of here and let's select 2. So when we select, it is very fast. Yeah, it's very fast, but we can see we're getting up to 57 there. We getting a lot of things there. Okay, but the way we're going to fix this, because we need to tabulate here, so which means we need to increase this also by 2, right? We need to increase these by 2. So to increase the y coordinate by 2, I will create another variable. I'll say y, and I will initialize it to be equal to 0. Then I'm going to come here and then add it to this variable y coordinate. Okay, then what we need to do here is basically we need to increment, right? We need to increment y by 1. Okay, so y plus equal 1, so that every time we are moving into the next y coordinate, and then we're going to print v out. But this is only basically applying for v out right now. But now let's print it. Let's put a sleep somewhere here. Okay, let's put a sleep function, and that way we can see what we are printing. And let's go ahead and give this a try. Okay, so 2, and you can see we've got a bunch of number. Now we're getting a voltage that is way too much. Okay, that is 57 volt. Now according to this data sheet here, the maximum output voltage, right, so it's from 1.25 to 37. So 37 volt is a maximum output voltage for an LM327, not 57. But we're getting 57 because we are doing a calculation here that is based on an input register that we entered here, which is 10,000. Now remember, as per the LM317 circuitry, these R2 here, basically set up the current. It does set up the current. That's the I adjust, right? I adjust is flowing through R2 here as well. So if R2 is very large, basically I adjust will decrease, and basically if I adjust is too small, So that just change your regulation, so the circuit will not operate anymore because the quiescent current is not the same anymore. So what we're going to do here, as you see here, I've plugged the 10k resistor potentiometer back. Now if I go all the way down, now you can see we're reading about 1.4 here. Okay, tolerances. Now as I start going up with my resistor potentiometer, as I start going up, now I did show you guys already how much is my input voltage here. So let's double check that. So the input voltage, just change my, so the input voltage is 14 volt, right? The input voltage is 14 volt. Let me just increase it here with my power supply. I want to make the input voltage this power supply can only go to 18 volt. Fine. So let's make the input volt here to be 18 volt. Okay. Now as I go up all the way, now I'm getting about 17 volt. Now it seems like my output voltage is not increasing anymore. It's have stopped to 17. Now I've reached the end of my potentiometer. Now notice this, as I start to come back, the value on my output does not change that much all the way until I'm almost right on the middle of the potentiometer here. Then that's where my voltage is actually starting to change. So what it means is, when the resistors of the potentiometer become too big, there is no more change on the output. It does not work anymore. Okay, does not work anymore. And that's precisely because I adjust current become too small. So here the calculation will still work, but it's not going to be real onto the breadboard. So in order to fix that, we have to look into the data sheet here. You can see what they have here. R1 here is 240 ohm and R2 is what? 2.4. So basically R2 is 10 times than R1. Now I indicated that my R1 here is 220 ohms, so which means I have to put my R2 at least 2200 ohms, so 2.2k. So I'm going to come here and change this to 2200, so that is 220k, and that way we can try to run this again. Okay, application error, what's going on? All right, now if I hit option 2 again, now you can see I'm getting my output all the way to 13, right? 13.4, 13.44. Now I want to change my output, rather R2, the value of my potentiometer here, to just increase it a little bit to something like 2.8, so that I can reflect at least the maximum that I got in there. Okay, so we make it 2.8 and then we check again. All right, so option 2, right, now we can see that we're getting 1702, the value of R2. Okay, the value of the output voltage. Okay, and and basically we are getting that part working. And also I've changed count here from starting from 10 to starting from 1. Okay, so that way we can get the first value to be very small. Okay, so now we are going to proceed by basically just displaying the rest of the variable. As you can see, R1 there, for the first one it's 1,26. okay, for count is equal to 1. So now let's basically proceed, and here, because we can see that we're getting V out to display properly. Now the only thing that is missing for us to display is basically R1 and R2. So we're going to use the same trick. So what I'm going to do here, I'm basically going to copy and then this should be 40, right? This should be 40, and this is going to be R2. And the next one, I think it should be 20, okay, and this is going to be R1. Okay, let's just double check what we've done here on the fixed. So it's 20, 40, 60. Okay, now let's give this a try. Okay, come on. Okay, number 2. Okay, now you can see we're getting R1 is 20 to 20 ohm all the way. Let me just increase here to 10 seconds so we can have enough time to basically look at the values that we are going to be dealing with here. Okay, so number 2. Okay, we can see that for R2 1 ohm, that's 126, and I'm not sure if we can get that 5 volt. It's gone. Let's come back again. So 5.55, it's 751. You can see between the 4 comma, so 3.4. Okay, this is still a bit too fast. Let's make it 20 seconds, right? That is quite a lot of time to wait for this program. All right, number 2 again. So 3.3 volts. So if we want 3.4, basically that's 376 for R2. So you can fine tune the increments here. Let's change the increment here and maybe increment these by 75 or by 110. Okay, so you can fine tune your increments here so that you can see if you can get the desired voltages that you might be looking for as you are making your design. Okay, so now you can see, right, you can see here 5 volt, right, 661 we getting, and 3.15, that's 330 ohm, that for R2, and all the other voltages as you go. So this is it, guys, for this tutorial. I hope you have learned something, and if you found it very useful, please don't forget to subscribe to CMTEQ channel and drop a comment on the comment box. That will be highly appreciated if you give this tutorial your thumbs up, as you can see, and continue to stay tuned for more tutorial of this nature from CMTEQ channel. Now you can see when I hit X, small letter X, and my program successfully exited successfully, right, or program successfully terminated, and it is actually displaying right on the center, right on the top. So if we want to display it on the center, what we can basically do here, we can say go to X, Y, and also pass the coordinate 10 and 20 here, and then you can run this again. Okay, and then I'm going to exit my program, this time with a capital X, and it says program exited successfully. So that is it, guys. Thank you and for watching, and go out there and go design your LM317 circuitry. Thanks for watching. Until next time, cheers.